Hey guys, Buildzoid here, and welcome to another RAM overclocking video. Oh no. But as you can see, today we've got some very green memory sticks. This stuff right here is Samsung OEM E-die, 4 gigabit E-die. So this is a 4 gig stick. I have two of them. The other one's already installed. And this is on an A1 PCB. So this is what A1 looks like. And the biggest difference, basically, there a lot of people say that like the A0 PCB is A1. It's not A1. The biggest difference between A0 and A1 is that this missing memory chip isn't present. And actually, A1 has a more similar layout to A2 than it does to A0 because the memory chips are closer to the actual gold fingers and spread further apart from each other, whereas on an A0 they're more like halfway up the memory stick instead of, rammed up against the edge of the stick. But the thing is, the A1 PCB should be pretty good at memory clock. Samsung E-die clocks ridiculously high in my past testing. So I picked up two of these sticks for I think around 30 quid, so not really that much. And we're on the B550 Aorus Master along with a 4750G. And I mostly want to see if I can make this stuff do 5 gigahertz. Yeah, that's basically it. I might also do some actual like practical settings with it because the funny thing about Samsung E-die is it is very, very like these OEM E-die sticks are extremely cheap. I'm not sure that they're that common these days, but they are extremely cheap. And the performance, because it's for like Samsung 4 gigabit E-die was the basically from a competitive overclocking perspective, it's the B-die predecessor. This is what you'd use before B-die was a thing. And now that B-die is a thing, we just use B-die because B-die does like this will do most of the same timings that B-die does, except for the TRCD and TRP. And also it's slightly weaker on TRFC. Like it's just slightly weaker across the board on the sub timings, but and then it's much weaker on the TRCD and TRP. Which is pretty normal. Like most memory chips don't really do a great TRCD or TRP. So yeah, we'll see what's possible today. Though I'm mostly going to be going for raw frequency with these because these are rated for 2133 out of the box. And I have one other stick of this that I've worked with in the past, and it did 4800 quite easily, and that was on Z390. Today we're using the 4750G, which is basically like out of the CPUs I own, it is the best memory controller I have. And so I'm kind of hoping that, with a better memory controller, we can go to 5000. So the only things I'm really going to be doing is I'm going to be setting our V-core to something somewhat low, not super low. Set our CPU ratio to anything other than stock. That disables the boost system. We're also going to do V-core SoC to 1.15. That's just what the CPU likes. DRAM voltage, we're going to go to 1.7. That's an arbitrarily high value. The fun thing, actually, Samsung E-die, what I really like about Samsung E-die compared to B-die is that you can whack 2 volts into this stuff, and unlike B-die, it doesn't need max mem. So if you're on B-die and you whack 2 volts into it, you can't address the entire memory array. So if you're trying to run benchmarks, you have to go into Windows, reduce how much memory Windows is able to address, and then you can start using really high voltages in excess of like 1.75 volts. With Samsung E-die, I mean, you can literally just whack 2 volts into it and call it a day. Not that I would run this long term, but at least the memory sticks really don't seem to care if you do this to them. So that's really, really cool about this memory chip. We're going to just start out with like 1.7. So anyway, for load line calibration on this board, we're going to go high. For SoC, I'm going to go high. We're going to max out all our protections, and that's it. We're not going to bother with the PWM phase control because it doesn't do anything. So GFX core voltage is just SoC voltage again, and the only thing I wanted to do... Oh wait, I can't remember if this is the BIOS with the buggy C states, so we're just going to disable those, but... The other thing I need to do is we're gonna go into NBIO. I don't know what BIOS we're even on. Wait, where's my FCLK settings? Oh no. Yeah, because it should be in here, under XFR, but apparently it isn't. Infinity Fabric. So this is annoying. We're just going to set it to 1800, which is super easy on these APUs. But again, I'm going for memory frequency. I don't really care about performance right now. That should work. Well, I might have to install Zen timings once we get into the OS. And then for memory settings, this stuff runs loose. So we're going to go 20, 28, 28, 20. Like TRCD and TRP are really weak on this stuff. So we might end up at like 30. Honestly. So yeah, I don't know where we're going to end up with the timings, but we're going to start with this. And actually I'm going to go all the way into the operating system with this setup right now. Because I want to check that the FCLK is actually like at 1800 and it's not doing anything weird and unexpected. The board has a surprisingly long post time on the APU. Then again, I don't know what BIOS version I'm on, so like it might just be me being an idiot. So yeah, but hey, I don't care about the post time as long as the memory clock's high enough. So just gonna throw Zen timings onto this, so that I can check that the CPU is doing what I told it to do. Okay, there's Zen timings. I'm gonna create a shortcut for it. So right now this is just running stock. Actually, right now it's running worse than stock because there's more voltage into it, and we're right. Just run. And FCLK is at 1800. You see that? Perfect. Okay, so we're gonna take a we're gonna go. I think like the way I like to go is normally start with like 3200. You know, like theoretically I should be able to skip all the way to 4000 and it won't make a difference, but I'm not sure that it'll immediately work. And I don't want to, like, if it immediately doesn't work at 4000, then, like, I don't want to have to walk through the whole procedure. So, come on, boot. Lovely. So 3200 works to absolutely no surprise. Technically, on a 2133 memory stick, that's already like a 50% overclock, but we're gonna, like, I want to go way past 2 times the stock speed. That's like the main reason I wanted a kit. Like, I've actually been kind of on the search for a A2 based E-die, like E-die memory sticks on an A2 PCB. Mostly because I've just kind of wanted to do ridiculous frequency with this memory chip. Because that's something I've never tried with it. And doing high frequency on B-die is generally very difficult. Just because of how hard B-die is to drive, but this stuff should be much easier. So actually, we're going to take that. We're going to go for the 4000. Because I think I went 3200, 3600, 4000. So next stop, 4400. Going to go up in increments of 400. It's not like you have to. There's no, like, there really, honestly, if I wasn't, like, the thing is, if I was actually doing this off camera, I'd probably skip straight to 4800, and when that doesn't work, I'd get really upset. But that's the thing, is, like, if you don't know what you're doing, you should walk it up. Actually, you should probably walk it up slower than what I'm doing here. I'm going in 400 megahertz increments, which is honestly kind of insane. But, you know, I've worked with this memory chip quite a lot in the past. I've even worked with one of these memory sticks, not 2 of them. It's kind of a big difference, but yeah. So, you know, I'll be, like, I fully expect it to go all the way up to, like, 4800 super easy. Also, this board this board is really strong at memory overclocking. It's either tied or second only to the Unify. Okay, so now we start getting to the annoying part of this, which is the F9 codes. So hopefully we don't trigger the recovery. And I didn't wire up a reset button. I wired up clear CMOS, but not reset. Well, now I have a reset button, so hopefully it didn't kick me onto the backup BIOS. I think it just recovered. The thing is, on the Unify, you'd have to like brute force your way through an F9 code sometimes. So I'm thinking this might be the same situation. Am I going to regret not wiring up clear CMOS? Hopefully not. Come on. And, oh, yay, okay, so the auto recovery actually worked, to my great surprise. So we're gonna go... We're just gonna call this one E, because E-die is good. So, I'm thinking we're just gonna try looser. Yeah, that seems like a sensible way of doing things. Procode ET should already be on the optimal value, which for this board would be 40 ohm. And I think we might have to... I'll try dropping CLK drive strength to 20. Yeah, okay, so if you just keep mashing reset, I think... Yeah, so the reset mashing thing works, I guess. At least this seems like it might work. Or did it? I can't tell. It's looping. Stop looping. No! What the hell? Oh, 05, 27, B2, finally! So did it recover, or did it actually work? It recovered. Damn it! Okay, that is not what I was hoping for. We need more voltage. And actually, we're gonna go down to 4666. F9 again. What the... No. I think the recovery is like the error recovery is working through the reset codes, which, well, through the resets, which is not what I wanted. Can't be stuck at 4400. That's really lame. Probably gonna have to fiddle with the Procode ET and like all of the settings, which I'm not very happy about. Yeah, so that definitely, I think, recovered. At least it's not kicking us to the backup BIOS. Because that would be super annoying. Okay, we're going to go down to 4400, because I think that's the last setting that worked. And we're going to see if my Procode ET setting is correct or not, I guess. And yeah, that seems to work just fine. Okay, so 4400, it's happy. I wonder if we can drop all the way down to 32 ohms. Oh, we can try. Like, evidently the auto recovery works just fine as long as you get an F9 code, so let's hope for an F9. Okay, no, that worked. Okay. Interesting. Like, it would make sense that the Procode ET changes based on the memory stick PCB as well as the memory ICs, so this being A1, it might need completely different resistance settings compared to the A2 memory sticks that I normally work with. Yeah, okay, so that's interesting. Can we do 4800 now? No. Damn it. Yeah, now it recovered. Right? Okay, I'm going to give it one more reset, and then I think it should have recovered after that. And apparently not. There we go. That's another recovery. Damn it. Maybe more SOC voltage? That might help. Nope. I think it recovered again. I need to go change the number of retries. Yeah, I need to change the retry count to something higher, because I don't think 3 retries is enough. Also, the auto recovery doesn't seem to be super consistent. There, now it finally kicked in. Still not as bad as some motherboards out there that just never recover, ever, until you clear the CMOS. Okay, so 4800 still doesn't work. Let's go down to, I guess, you know what, let's do this the reasonable people way. 4466. Does that work? No. Okay. That's bad. That's really bad. That's like super bad. So it only works up to 4400, which is like that's a problem. I wonder if the memory isn't set to 2 to 1 or something. Like maybe the board isn't automatically setting into 2 to 1 mode, and so it's trying to run 4800 at 1 to 1, which I think there's some APUs that can do that, but I don't think this one can. Because like 4466 really shouldn't be an issue, especially since 4400 works just fine. Unless I screwed up the proc ODT setting. Or there might be some kind of subtiming issue. BIOS, okay. Nope. Well, we could disable this. Not that I expect that to do anything. No, that's not what I wanted. Where is 2 to 1 mode? Down here. Oh, there's XFR enhancement. Ah. There. That should help. Go down to 4400 again. $4,400 works, as expected. Awesome. Okay, that's that. Let's try 4466 again. Please work this time. No. But why won't you work? What am I doing wrong? That's CL22. That should be plenty, especially with how much voltage I'm running into it. CL20 should be plenty. Also, the auto recovery on this board takes way too long, and I think it like needs a reset partway through. 39, yeah. Okay, enter BIOS. So that is really annoying. So I was expecting to be able to do this on like auto timings. But apparently not. Actually, we could go all the way up to 20 on that. And we shouldn't, I really shouldn't have to set anything else. I don't think. Was that it? Was it literally just TCWL? Oh, and I guess proc ODT as well. Okay, so maybe 32 ohm is not optimal for this memory configuration. Yeah, okay, so 32 ohm, bad idea. 4533. Please no F9. Yay, progress. Okay, like we're comfortably at twice the rated speed of the memory kit at this point, so like technically by most people's standards this would be a victory at this point, but it's like no, I want 5 gigahertz out of a 133 memory stick. 4600. Okay, it's doing it. It's doing it. Good. The hell is 5F? I've never seen that one. That's new. That's also new. I've never seen that postcode before, so I have no idea what that means. Okay, 5, like, again, the 5F board, give me a code that I can work with. Give me an F9 or something. No, that's not an F9. Is it not going to auto-recover now? Did I break the auto-recovery? Yay, I broke the auto-recovery! Progress! Also, I swear I just saw a 55. It's turning into Z490 all over again. So I'm just hitting reset. That's why it's looping so quickly. My theory being if I reset it at the 15 code, it'll go into the into the recovery function. I'm doing it a little early. Because normally if you reset on F9, like it would eventually trigger the recovery. So I'm thinking like if I just reset it at the right point, it'll eventually trigger. Except it won't. Imagine if AMD didn't, like, if we could just have safe boot instead of AMD's automatic recovery system. Which, like, when it works, it's great, but a lot of the time it does this. I don't want to clear CMOS. I spent way too much time digging around Gigabyte submenus, which, if I remember correctly, on some BIOS versions, those don't even get saved. Like if you set something in those like AMD overclocking menu or something, like they don't get saved properly on some BIOS versions. So like I really, really don't want to clear CMOS right now. Boot, please. That's like almost 9A is like really, really close to booting. Or at least most of the time it would be. Wait, nope, that did not trigger the auto recovery. Did I? Nope, that still didn't trigger it. I don't know, like, why they didn't implement some kind of... Like, the problem with the auto recovery is that it evidently needs to, like, be stable to some extent, or, like, it only recovers from certain errors, not, like, general instability. And there's no reliable way to trigger it. Like, if it was like, yeah, just triple tap reset, and then you get auto recovery or something. But no, no, you just gotta sit there and hope that the board like, magically figures out that something isn't working when it isn't working. Oh, well. So I guess clear CMOS it is. What a horrible solution. With any luck, the last known good will still be, well, actually, no, the last known good won't be saved. I'll still have to set everything up again. What? I just cleared the ZMOS. Why are you stuck on 36? What is wrong with you, board? Wait, did it go to the backup BIOS and now I'm, like, stuck on a BIOS that isn't even compatible with the APU? There's a decent chance it's done that. Man, this is what I get for feeling bad for this board sitting in its box all the time, because it's like, I could have just gone and pulled out the Unify again, but I was like, oh, let's try a different board. It'll be interesting. And it's just like, oh no, this is why I didn't try to do 5 gigahertz, like, didn't try to do my max frequency, memory frequency validation with this board. This right here. This is exactly why I didn't do that. Because I think there's a pretty decent chance that this board would actually get very close to what the Unify managed. Because from some of the testing I've done on both boards in terms of memory overclocking, they seem very similar. The only issue is this board is really badly behaved. So, you know, it's like, yeah, technically it's probably capable of achieving the same thing. You just have to be far, far more patient. And it's just like, well, that's disappointing, isn't it? Boot, damn it. Why isn't it booting again? This board seems to have some kind of issue with detecting the APU for some reason. Oh, there we go. Finally. Oh, this is like Threadripper all over again. You clear the CMOS and then you sit there for half a minute waiting for the motherboard to figure out that it's supposed to turn on and how to do that. Okay, so we're going to load up last known good with any luck. Well, that didn't do at all what I wanted. So let's try to load up E. I don't think that has most of the settings that I needed, right? Nope. Gonna go back to 40 ohm. Still want the low CLK drive strength. Like, generally that seemed to like, in the past that usually helped. Guess we could try disable gear down mode and run 2T command rate instead of 1T command rate. Or, well, instead of running gear down mode, because 2T like straight up 2T is often more stable than gear down mode. It's also slower, but it's more stable. So in this case, you know, I don't care about speed. We're going for max frequency, so I don't care if it's slow. I just need it to boot. Yeah, that actually shouldn't be necessary anyway. So, oh, so that, this is a fun one. So, on some BIOS versions, this clears. On some, it doesn't. So, on this one, it doesn't, because that's still 1800. So, what else did I want to change? Though I built, yeah, AMD CBS, on the other hand, I'm pretty sure did clear. Yeah. So UCLK to MCLK divided by 2. Now we're going to go back to 4533. I'm going to hit it with 1.8 volts again. Okay, so we're back before the whole, oh, I can't get it to recover moment. This video is going to turn out way longer than I was hoping it would, but oh well. Welcome to the AHOC experience. Like, I was like, oh, yeah, you know, let's do a 30-minute memory overclock. How long can it possibly take to do 5,000 on a memory kit rated for 2133? Evidently, I am really bad at estimating how long something's going to take. I'm going to go back up to 4600. I should have saved a profile. Damn it. Did I just get myself back into the situation I was in before? I'm pretty sure I did. Why is it always CPU? Like, I think that's CPU error. Oh no, that's GPU error. Like that LED. So that's GPU initialization, this one. So like it's basically what's happening is it's unstable. I wonder if I just pull a memory stick if it'll start working. Because the second memory stick, like the far away memory channel, clocks worse than the primary. No, that didn't help. Damn it. Or at least it didn't help enough. Yeah, no, that didn't help at all. So I'll try pull the other stick. I guess what I could do is I could put a stick on the before last slot of the daisy chain, and that'll crash the memory controller, and then it might trigger the recovery. I wonder if there would be a better way to do that. Like intentionally crashing the memory controller. Like, so instead of getting stuck on like 54, which the board won't recover from, like forcing an F9 code. So I'll actually show you what I'm doing right now. So you can see that now I've moved the memory stick one slot in. So it's now on the wrong memory slot for a single stick per channel. But I'm hoping, because this memory slot clocks worse, it'll trigger the recovery because we won't be able to, because basically when it gives you an F9 code, it means like the memory training failed. Well, if we're on the wrong DIMM slot, it should fail. So hopefully this will force the recovery to kick in. Get 15. What? No, not supposed to do that. What are you doing, board? How is it not F9ing? I think it's in the auto recovery at this point. Because it's like looping through the codes instead of just getting stuck on 54. So maybe my dumb idea kind of worked, but it didn't work the way I wanted it to work, so that's not great. We still have to deal with the fact that the recovery mode doesn't like kick in properly. There, yeah, no, damn it. I get excited when I see the 39 code, because normally that's followed by 27 and B2. Why won't... Oh, finally it recovered. Yay, so we don't have to... My settings are gone. Wait, what BIOS are we on? Oh no, we're on the backup BIOS. Well, this gives me a great opportunity to... So it's really funny. So as you may know, I've mentioned that I want to mod this board to not have dual BIOS functionality. And the thing is, the circuitry for that is actually way more complicated than I thought it would be. So this gives me a great opportunity to take a measurement that I couldn't take because I couldn't get the board to go to the backup BIOS last time I was trying to figure out how to get how to modify it. But well, now it's on the backup BIOS, so I'm gonna go stab it with the multimeter. Actually, I have a better idea for how to do that. Ta-da! Very interesting. I'm not sure what to do about that. So basically, the documentation for the BIOS chips told me which pins are used for which pin on the BIOS chip is chip select, but it turns out that the chip select pin doesn't just sit at a fixed voltage level. And so I was really hoping that there'd just be like a transistor behaving like a switch, which connects one BIOS chip and disconnects the other. But what actually happens is that one BIOS chip sits at 2 volts, at least according to the multimeter. Ideally, I'd be stabbing it with an oscilloscope. But one BIOS chip, like right now, the backup BIOS chip has 2 volts on the chip select, whereas the other one is at 1.8 volts. And then in the opposite situation, and then when you're on the main BIOS chip, you get 2 volts on the main BIOS chip, you get 1.8 volts on the backup BIOS chip select. So I guess what I could do is basically... The thing is, I don't know where those voltages come from, which is a real problem. It's a pretty major problem. Give me a second. Yeah, so what I'm thinking is I need to figure out some way to connect the 2 volts to, like, to be able to arbitrarily choose which BIOS chip is connected to the 2 volts that it's connected to right now. Because there's like a bunch of transistors doing all the switching for where the rail goes. Or, well, rail, where that, like, where the chip select comes from. So basically, well, theoretically, it should just be a matter of, like, shuffling that voltage around in, like, from, like, right now it's 2 volts on the backup, 1.8 volts on the main. So if I figure out where those 2 voltages come from, I can just switch them around with my own circuitry, and then I'll get full manual control over which BIOS chip is being selected. Instead of letting the board randomly decide for me that, hey, I'm just going to go to the backup BIOS chip. Not when you're actually trying to measure that. No, when you're trying to do a memory overclock, that's when I'll do that. Anyway, cycling the standby power is enough to get the board to switch back over to the main BIOS chip. F9! Yes! So my idea did work. Now I just have to hit the reset button a couple times. I wonder if there's some way I could hard crash the, like... Because here's the thing, like, obviously the memory controller will crash if you, like, short out the data lines or something. But I'm not sure that that's a very safe thing to do, so we're not gonna do that. So I'm kind of wondering is there some way that I could... Actually, like, the issue is, like, anything you connect to the DIMM slots is going to be a problem. So, like, whatever it is, it has to be super non-intrusive. Which is a real problem. Because I can't really think of how to do that. Oh wait, we're on the wrong DIMM slot. It's not gonna work. Oh. Well. I think that worked. Come on. Boot already. Don't tell me it already triggered recovery. It shouldn't trigger recovery. We failed to boot once. Unless it went to the backup BIOS chip again, in which case, like... Huh? Oh, no, it worked, but it's super unstable again. But why is it so unstable all the time? Oh man, yeah, it's back to being super mega unstable. Okay, well, we're gonna F9 it again. I guess. Yeah, I'm gonna F9 it. There has to be a way to trigger that. Like, if you could reliably trigger the F9 post code, like, it would make AMD overclocking so much easier. Or more convenient. So, more convenient, not easier. There, see? So now we get F9. I can hit reset. I can hit reset. I can hit reset. And now it recovers because we have hit F9 3 times in a row. So basically, all, like... Oh, I guess you could just drop the memory voltage really low. Yeah, that should do it. If you like turned off the memory VRM, that should do it. Or just have a like a 0.8 volt setting on the memory or something. Yeah, if you drop the memory voltage low enough, it should just not boot. So yeah, that's one way I could crash it. Though I think honestly setting it to like actually like booting up at 0 volts should be even better because then it's not, well, actually no, that might be a major problem again. Because like what I'm basically wondering about is like if I set the memory voltage to 1 volt, which is 200 millivolts below spec, it's like that's going to be fine. Like I don't think there's any safety concerns with that. But I also think there's a good chance that you won't get the F9 code as reliably as you'd like to. So that's not a great way of doing, like, that's not really a great way to achieve what I'm aiming for, which is to be able to trigger F9 codes with like 100% reliability whenever you feel like it. That's what I want. But I think running really low VDIM would probably be the easiest way of doing that. Like maybe if you tried to boot at like half a volt memory voltage, it'll like the thing is I'm kind of concerned if like half a volt won't be a health hazard for anything. Because you can technically, like, there are certain scenarios where if a voltage is too low, it can cause issues. So, anyway, we're going to have to switch DIMM slots on this because it's going to F9 again. Yeah, I think I'll take one of my, like, cheapo boards. Or, well, I'll take one of my motherboards that I don't like very much. No, but I do need the postcode. Because the thing is, I need the postcode to be able to tell if it's hitting an F9 code. So it's like, I need a board that I don't like, but it does have a postcode. And it has a reliable auto recovery system. I know! B550 Steel Legend. Oh, okay, so it is so you might be looking at this like Buildzoid. It just booted at 4600 with 1.65 volts. Why is that? Why wasn't it booting at 1.8 volts? Well, I'll tell you why. I'm pretty sure the termination voltage was too high. And so at 1.65 volts, the VTT DDR is more optimal. So anyway, now we can go up in the frequency again. And I have another dumb idea to potentially test on a motherboard once I sort out the mess that is in the soldering area of my desk. Okay, so this time reset worked the way I wanted it to. Please boot. Like, evidently you can train this, so come on, boot. This feels almost like trying to do high frequency on A0 memory. Not fun. A0, the PCB, basically has a hard wall at 4666. Like, hard wall. So, yeah, I don't have high hopes at this point. I'm kind of thinking I should set the VTT DDR to... No, you know what's really stupid? VTT DDR on Gigabyte boards used to be like you would just punch in a number and it was that number. And now they have it implemented as a voltage offset. I don't know why, but it's dumb and I don't like it. And we're going to offset it to like minus 60. And I'm going to go up to 1.7. We're going to try this. Magic. Okay, well, nope, that didn't work. And it looked so good for a little bit. Okay, it looks good again. Oh man, I don't think the A1 PCB is designed to go this fast. Like, it's already complaining. I really want an A2 E-die kit. Like, it would be so much better for doing this kind of thing. I'm going to try lower the VTT DDR even more. How bad are the timings at this point? Horrendous. That's how bad. 4800, here we go. I want to beat my old record, though. Like, my old record for this PCB with this memory chip is actually 4800. So if we can't beat 4800, that's a massive fail in my book. And we just triggered the auto recovery, which is fine. Which is fine. It's better than being stuck on postcodes that don't let you recover. I think I'm going to title this video Going Full Buildzoid. Horrible cheap RAM on kind of expensive motherboard with very expensive CPU. Random measuring of things that are irrelevant for modification and sketchy modification ideas being thrown about. Like, yep, this is going full Buildzoid. Okay, so 4800, no worky. I have no idea why. Maybe I should lower the voltage again. Maybe I was wrong. Maybe we don't need more VDIM. Maybe it really does like 1.65 volts best. We're still going to keep the VTT DDR offset. Oh yeah, it just kind of likes 1.65 better. And then it 5Fs on you. So now it's not going to want to recover again. Yeah, it's not going to want to recover now. Damn it. I don't know what 79 is. Okay, we're F9ing it. I'm putting it into the wrong DIMM slot again. So now it'll F9, then we can reset, and it'll F9 again, we can reset, and it'll F9 again, we can reset, and then it'll trigger the auto recovery. It's amazing! Yeah, so there's, like, obviously I need to figure out a way to trigger that without having to switch the memory stick around, because, like, that would be like superpowers on this motherboard. If I could just trigger the auto recovery whenever, for whatever reason, that would be just perfect. I actually don't know why AMD didn't integrate that functionality into the CPUs, because like they already implement it or into their BIOS, like some way to force the F9 code or force the auto recovery condition. Because that would be so cool. I'm going to bring this back up to auto, or more like 0. Yeah, let's try this. And the thing is, I'm going to have to switch the DIMM slots again, because it's just going to F9. Right, because we're on the wrong DIMM slot. The stick might be getting too hot, which is why I have to keep walking the voltage down, or it's just a termination thing. Could be both. You never know with RAM. You never know. Okay, it doesn't. Okay, I think it just doesn't like the voltage super high. Okay, so we're at 4800. If we do 5 gigahertz at 1.2 volts, I will be very surprised. Come on. I believe in you, motherboard. Yes, motherboard. Good. Now just keep working. Okay, 4866. Oh, man. We're gonna have to put the second memory stick back in eventually. And that's when everything's gonna go horribly wrong. Okay, so my suspicion that 0.8 VTT DDR was probably the correct VTT DDR is turning out to be very correct, apparently. Or maybe it just needs to be 800, 800 millivolts below VDIM. One of the two. Like, either it's a relationship of VTT DDR to VDIM, or it's VTT DDR as an absolute value. It can vary. Anyway, I'm gonna set that to 50. Oh, come on. You can't do that to me now. We've gotten so far. And I'm running out of tricks. I'm gonna lower the voltage again. Like, maybe the PCB has some, like, weird interaction at high VDIM. Also, this is an OEM Samsung PCB, so it's, like, not designed for this kind... Like, the thing is, even though, like, a custom PCB from a company like Team Group or G-Skill or Corsair or whatever, like, it'll still use the same, like, A2 layout or an A1 layout or an A0 layout. They'll generally have some further optimizations done to them. Or Crucial as well also runs non-standard PCBs. So they'll have some optimizations done to them for better overclocking range. The thing, like, I wish I could say specifically what they've done, but I don't know, and they won't tell me because it's like it's one of the few ways the memory vendors can differentiate themselves is like who can build a better PCB, but. Okay, that's F9ing again. Okay, I don't think it... yeah, no, so this seems to be, again, a little bit too much VDIM. Which I'm super surprised by, because E-die generally shouldn't care. It seems to need less and less like, it seems to straight up require lower and lower voltages as I keep raising the frequency. Which is pretty funny. Man, I wish I had, like, proper A2 PCBs on these memory sticks. I think it would be a really cool, like... Well, the thing is, there wouldn't really be much of a market for a, 2x4 ultra-high frequency memory kit that's also kind of loose. Okay, let's try 1.5, because, like, it keeps training the lower I get the voltage, so... The thing is, this also means we can't lower the timings, because the timings scale with voltage. So if I run low voltage, we can't do super tight timings, because... You need high voltage for tight timings. So we need... Oh man, it did 5. Okay, we're going to go all the way to Windows. Right, because it doesn't count unless you can take a screenshot. And BIOS screenshots don't count. Fun fact. Honestly, considering the fact that we're, like, booting 5 gig, I think if I had to, we could BCLK to 5 gig in the operating system, but... No, it just does 5 gig. Yeah, now imagine if they still made... Like, the thing is, as far as I'm aware, they still sell E-die on proper memory sticks. It's just that they're, like, on, like, proper PCBs. The problem is you can't get them reliably, because they're going to be in, like, a 3200 CL16 kit, and there's or a 2400 CL16 kit. Like, they're going to just be in random, trash bins, And so some of the sticks in that speed grade will be E-die, right? This stuff, and absolutely bloody amazing. And most of them will be some random Hynix or Micron IC or some random Samsung IC that isn't that great. And yeah, you'll be screwed. So that's 2,500. 5 gig. Yay, me. Let's put the second stick in and see if it still works. Funny that it needs really low volt, like 1.5 volts for 5 gig is really low, as far as I'm concerned. Like, that's low. Like, most of my past 5 gig attempts have included, well, ignoring the crazy Crucial Ballistics 5 gigahertz kit, most of my other 5 gigahertz attempts require around 1.55 to like 1.7 volts. So this being a 1.5 volt 5 gig is like, damn. The timings suck, but still, damn. Like, it's 5 gig. Yeah, so that's exactly what I was expecting when I installed the second memory stick. Because now there's like, like, first of all, we don't know the silicon quality of both of these sticks, so there's a chance the second one is worse. Also, but it looks like the memory controller figured it out. Okay, so we're gonna just go all the way straight to Windows again. Oh yeah. You know what? We should run Geekbench with these settings. I don't think it'll... Oh, okay, wait. I wonder if I just need to lower the voltage some more. Which would be, to me, that's absolutely hilarious. It's like, yeah, so in order to improve your overclock stability, you need to lower the voltage. To be fair, Samsung C-die, which is an 8 gigabit memory chip and the successor of Samsung B-die, straight up overclocks like trash at 1.5 volts. Like, it literally, like, it barely even freaking functions at 1.5 volts. And at 1.6, it basically does, like, it, like, the quickest way to figure out if your memory stick is Samsung C-die is to try boot 3200 CL, like, to try boot 3200 at, like, CL18 or whatever, but with 1.6 volts. Because if you're on C-die, that won't work. So anyway, let's try 1.4. Okay, I don't think 1.4 is a good idea. We're going to try 1.45. It's a good thing that the APUs have an extended like timing range, because if we couldn't run timings this loose, then I don't think it would work. Okay, so now the voltage is too low. Oh man, this is okay. This is quite the balancing act I need to run here, where it's like, okay, your VDIM can't be too high, but it also can't be too low, which is a problem. That's a major problem right there. Should just be the auto recovery again, right? Yep. Okay, so 1.45 volts is too low. So what about like 1.55, but with minus 35 millivolts? And yeah, I don't think we can do anything. I don't think I can loosen these out anymore. Or more like, I don't think loosening out any more timings more is going to do anything at this point. Okay, that F9's. Okay, that's bad. Yeah, that F9's super hard. Okay, maybe it needs more VTT DDR? So it might be... It might not be absolute value, it might be proximity. So, like, how close is VTT DDR to VDIM? And VTT DDR by spec is supposed to be half VDIM, which is why I've been talking about VTT DDR changing, even though I've been leaving it at, like, 0 volts adjustment. Because 1.6 volts on auto settings will get you 0.8 volts VTT DDR. And 1.5 volts on auto settings will get you 0.75. So for this, I want to try that. Oh, whoa. I did not expect such a massive difference from such a small adjustment. I might have to raise it, like, even further. Yeah, because now it sometimes trains and then it just crashes because I think it's still unstable. Yeah, it's just unstable now. Which means it's not going to recover until I put a memory stick in the wrong DIMM slot. Damn it. Okay, there we go. That's how you F9 your system. You put your memory sticks next to each other on a daisy chain topology. If you were on a T topology, or, well, it depends on which flavor of T topology, because some T topologies actually won't tolerate this memory stick layout, but there are some that literally don't care at all. Like, you could have the memory sticks right next to each other, you can have them as far apart as they go. Yeah, so some T topologies don't care, some do. But all daisy chains care a lot. Like, if you put your memory stick on the wrong slot on a daisy chain, you might not be even able to boot JDEC in some situations. But that's pretty unlikely. So back to the BIOS we go. And we're going to now raise termination even higher. Then we're going to shut down. It's going to F9 because we're on the wrong DIMM slot again. Shut it down. And no, wait, is it now too high? Oh no, it's too high now. Or is it? Oh, please, please, work? I think it might have auto-recovered. Maybe? Yeah, I think it's in the recovery state. Kinda hard to tell. Yeah, I think it's an auto-recovery. Okay, I think I'm gonna bring the voltage back up now. Like, I want both sticks in Windows at 5 gigahertz. Because if I only was doing it with one stick, I didn't need to buy two sticks. F9. The idea here being that now we're at 0.9 VTT DDR, 1.6 volts, and it's worse. Okay. It is way worse. I think we're in auto recovery again. I need to count how many times I hit the reset. So I'm losing track of it too quickly. Oh no! 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 Why would you do that? Well, that's it for the video. I'm done here. This is what, like an hour and 10 minutes? Yeah. So one of the sticks did 5 gigahertz. I'm pretty sure if I fiddle with the settings for long enough, I'll eventually get both sticks to 5 gigahertz all the way to Windows. But yeah. Like, I just freaking reset the BIOS. I mean, I didn't change that many settings, but the other thing is, like, the video is also, like, an hour and 10 minutes long at this point. And so I kind of feel like finishing this here. Well, actually, I feel like finishing the video. I don't really want to give up on the memory overclock, but it's like I'm kind of tired of, you know, making a video, if that makes sense. So, yeah, that's it. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. And both of those help out immensely with running the channel because they allow me to do things like picking up random low-spec memory sticks off of eBay. So yeah, it would be much appreciated if you'd check out the Patreon and Teespring. And that's it for the video. Thanks for watching, and goodbye.